So this is the second part of 6.2.2 when we're looking at combining random variables, putting them together. How does that affect the mean and standard deviation? So the work we're going to do in this section talks about finding the probability for a value of t that's a combination of two other variables. And one of the things that's really important to understand is when we are dealing with combining, we can only combine when it comes to variations specifically if they're independent. So it's important that we do a quick review of independent random variables. Two variables are independent. If knowing one is not going to help you to understand the probability of another, they don't affect one another. So when we were looking at probability models before, the way we proved if two things were independent was if we found the probability of one thing, like the probability of A, and found out that the probability of A given the other variable, they're exactly the same. So it wouldn't matter if you knew about B, it wouldn't matter if you didn't know about B, they're the same probability. So that's how the probability model looks at it. And we find in a linear model, if we were looking at the connection between A and B, we would find a total scatter. It would be a super low to zero correlation. And then if on the test you are unclear whether it's independent, but always look at the clues about whether it is or not, and they probably are going to say that it's independent. If not, and it's a free response question, state, assuming that these things are independent, so they know that you recognize that it's really important to understand independence. So we're going to look back at our Jeep situation where we had Pete and Aaron. They both ran a similar company in different parts of the state, unrelated to one another. So it's reasonable to assume that these two variables are independent of one another. Pete's success doesn't affect Aaron or vice versa because they are in a completely different part of the country. So we're going to go ahead and look at if we can talk about the average passenger over lots and lots and lots of days of tracking. For Pete was 3.75 passengers and for Aaron was 3.10. And when we're talking about combining these two, so if we wanted to find the new average, remember we find the average or the expected value of discrete random variables by multiplying. I'm going to blow this up a little bit. By multiplying the probability of, for example, this is Pete's, the probability that he has two passengers, and you multiply it by 0.15, and that would give you that part of the average, and then you add the next one, the next one, the next one. So if you're looking for the combination of these two, then this is the probabilities for Pete having two passengers, and this is the probability of Aaron having two passengers. So the probability that together they have four would be 0.15 times 0.03, which is 0.45, and then you would multiply that by the 4, and you get that. And then you do it again. We would take, here's the probability that Pete has 2, and Aaron has 3, and then you'd go ahead and take that 5 and multiply it by the probabilities of both of those happening, so 0.15 and 0.04, and then you get another sum. Then we'd add them all up, and we would go ahead and get the new average. But we don't have to do all that work, because what happens is, so instead of having to do the combination, all the combinations that would get you 4, and then all the combinations that would get you 5 this way, we don't have to do that. When they are independent, and we're looking at the means, all we have to do is say, well, if he's got an average of 3.75 and she's got an average of 3.10, we just need to add them together. So here is the distribution of them together. Sure enough, the middle is going to be that 3.65 plus the 3.10, and here we get 6.75, which is right here about in the middle. So with means, all you have to do is add the averages of, or the expected value of each of the random variables, and you're done. However, the standard deviation is a whole nother ball of wax. The deviations, we have to pay attention instead of adding the standard deviations, which doesn't work. This only works, by the way, with independent variables. We're going to go ahead and take the variance. It's the variances that end up being added together, and then you have to go back and do the standard deviation. So remember, the variance is what happens before you take the square root. So the variance here is the standard deviation squared, and it's 1.1881. And the variance for this one would be 0.943 squared. So 0.943 times 0.943 is going to give us a variance for Aaron of 0.8892. Now, we generally don't talk about variances. We talk about the standard deviation, but we need the variance for this part. So now, if we were going to find the new standard deviation, we would go through that process for standard deviation for random variables. And so we would go ahead and take, for this one right here, for example, we would take the 4 minus the new 6.85 mean, square it, and then multiply it by that 0.045, and continue that process, adding them all together. So you're going to take the 5 and minus the 6.85 squared times 0.060. And you're going to do that. You're going to add all of those up. And that is your variance. And what we find is that the variances of the x and y add together, and then you have to go ahead and take the square root to find this. So this is supposed to have the variance. So when, and this is really important, you cannot talk about the variance changing and then calculating the standard deviation if the random variables are not independent. So if there's some sort of connection between them, you can add the means, but you can't do that with the variance and then the standard deviation. So in this case, if they are independent, and Aaron and Pete's stuff is independent, so we're going to go ahead and we can, to find the total, the variation in the passengers for Aaron and Pete's together, we're going to go ahead and take their variance and add them together, and then to find the standard deviation, we just have to take the square root of that. So we're going to take the square root of the variance for x and the square root of the variance for y, and that's going to go ahead and give us our new variance. This is like, write it down 675 times. You can only add variances only when they're independent. You can't add the standard deviations. So we just talked about combining, adding, but you could also subtract random variables. There might be a reason to do that. And so if you're subtracting the random variables, then their means are subtracted. And once again, it doesn't matter if to combine or subtract means, you can do them if they're not independent. But of course, the order of subtraction is important. Now, if you have, you're subtracting two random variables and they are independent, then you can go ahead and, interestingly enough, you're going to add the variances anyway, and then go and take that square root of the sum of the variances. And pardon my really bad symbol drawing. So this is going to get you your standard deviation of the new one of D. No one heard me. This is a situation where we're going to be looking to see about 4 packets, and we only have information about 1 packet, and we want to know if after he's put the 4 packets, what are the chances it's going to be what he wants. And so he likes between 8.5 and 9 grams of sugar in his tea, and the packets have an average of 2.17 and a standard deviation of 0.08. So here we're going to go ahead and pretty straightforward. If the average packet is 2.17, then 4 of them are going to be 2.17 plus 2.17 plus 2.17 plus 2.17. So 4 of them together, we can expect an average of 8.68. However, These are independent of one another, so we can do the next piece, but we're not going to go ahead and add 0.08 plus 0.08 plus 0.08 plus 0.08 because that's a standard deviation. Instead, we're going to square that to get our variance. That's right there. And once again, the symbol didn't come through here, so here's our sigma. We're going to square that to find the variance for the first one, and then the variance of the second one, variance of the third one, variance of the fourth one, and that gives us the variance of the four put together, and that's our total. And then once we take that square root, we end up with 0.16. So that's the first thing you have to understand when you get a problem like this, is you've got to first recognize that you can go ahead and just add four of them, right? But the standard deviation, you're going to go ahead and square it to find the variance, adding that, and then taking the square. Oh no, we're not done. Now that we've gone and added 4 packets of sugar, then we know that the new average is 0.868 and our new standard deviation. So we have to build our new normal curve, because it said there's a normal distribution. And remember, when we add or combine normal distributions, they're going to keep that shape, even though they're going to have a different mean and a different standard deviation. So we're going to go ahead and take our 8.68. We're going to add 0.16, 0.16, 0.16. And then we go ahead and take a quick write a quick drawing of what we're looking for. We're looking at how he likes it from 8.5 to 9. And so we're going to go ahead and use what we know using either z-scores and subtraction or normal CDF. So there are 2 ways to find the probability that you're going to, and when you're doing the probability, you're looking for that area under the curve. And the tools we have to use are our calculator, which I'm going to explain last, and our z-scores, and the table. So first I'm going to blow it up so you can go ahead and see how to do it with the z-scores. So first thing, finding a z-score, remember, is the boundary point of interest minus the mean divided by the standard deviation. And this particular one has a negative z-score, which you can see right here. There it is at negative 1.13. And if we looked in the table, it would align with 0.1292. So there's a 0.1292 probability, or a 12.9% probability that it's going to be less than 8.5. So we just calculated this piece right there. And then we're going to look at the second boundary, which is right here at 2 standard deviations. So we actually didn't have to do the math if we'd already built it. So that one is at a 0.9772% chance. So we could go ahead and subtract those, because we want the area of the blue part, that is the whole thing from here back minus the yellow. So it's about 85% of the chance that his tea's going to taste right. And then if we look at the calculator way, the calculator does all this work for you. You have to write down that what you're putting into the calculator, both in general, what normal CDF command requires. It requires a lower boundary and upper boundary, the mean and the standard deviation of interest. In this particular case, the lower boundary is that 8.5, which is right here. Upper boundary is the 9, which is right there. And then our new standard deviation, our new mean when we combined all 4 packets was 8.68, and our new variation when we combined all 4 packets and took the variance and then took the square root was 0.16. And so it's still going to give you this 0.8480, so about 85%. Remember, answer the question. It's not just that you do the math, but that you have to answer the question. And so in this case, you're going to say about 85% chance that Mr. Starnes' tea will taste right. To me, this is a doozy of a chapter. It's hard to keep track of all of the new symbols and what's going on, but remember most of the things are common sense, that you can add the means, and that you have to deal with the standard deviation. Being a variance is a little more complicated, but we'll practice this a lot, so we'll get good.